Alright, let me just check real quick if it's living. Yeah, saying I'm living. Write this out. Write this down. Just stick this here. Alright, just move this and we can work around it. Oh wait. Bro. Let me see. Alright, let me just post the live stream. Where is tot göra på det? Alright. Just copy it and post it in my post at the LCMP so people knows about it. Alright. So we're ready. So like in this live stream we're gonna like discuss about the future of the rendering for this project. Alright. Most of the people are just trying to replace the rendering by using a other well-known graphics API like Vulkan. You got OpenGL, but it's old. And then you got DirectX, and no one would like to work with DirectX, but most of them are working with Vulkan. The problem with Vulkan is it's verbose. There's a lot of boilerplate, and there's a lot of difficulties in it, and every time they release a new update for the Vulkan API, then the team that is responsible for the render, who is gonna like they need to update the Vulkan API and their render to be compatible with the newer Vulkan API. So what big companies tend to do to avoid this issue, basically, they tend to use a cross-platform graphics library that supports wide ranges of graphics APIs and wide ranges of platforms, and has proven that it's sustainable and it's maintainable. And the library that I'm going to use and experiment it, basically try to implement a simple rendering in it, and it's called BGFX. Let me just bring it up real quick. BGFX. And this library has been used in a AAA game studios and big games and big game engines, and it's been like it's been out for more than 10 years, so it's proven a successful library, rendering library. So this BGFX, it supports wide ranges of graphics API. You got Direct 3D 11, 12, you got GNM. If you got a PS4 SDK license, basically you can just use its API and implement a port to PS4. It supports Metal, OpenGL 2.1, OpenGL 3.1, and OpenGL Embedded System 3.1. You got Vulkan, WebGL 1.0, 2.0, WebGP. Like, there's a lot of graphics APIs and graphics backends that it supports. So basically, you got one code base with multiple backends API, not like the others. How you say, other forks that we see, like Minecraft Smart CMD, Minecraft Console fork. They're tending to use just Vulkan, but this library supports multiple backends. So you got, if you want to run it on Mac, you got Metal. If you want, you can switch to Vulkan. And if you want to play it on older operating systems, like maybe Windows Vista XP, bro, you got OpenGL, and I believe OpenGL 2.1 does work on Windows XP. I believe so. And the supported platforms, we got Android and iOS, tvOS, blah blah blah. You got Linux, you got Mac OS, PlayStation 4, and of course 5, Raspberry Pi, Windows, Wasm, Windows 7 Plus. So what it does, it supports Raspberry Pi. This is the cool thing. If it supports Raspberry Pi, then what it means, it will you can basically run it on a RetroPie. Like, you know, RetroPie, you got old games from arcade games. You could think like you can play Minecraft in the arcade library directly without having a desktop or a desktop computer, just from just a RetroPie, and just to run it. Like, it would be very amazing. And it does support like controllers, so it's gonna be, if we embed it, if we use this library, then we will easily achieve these platforms. And it's like, code base is very good. It's not bad. What's up, dude? And there's a lot of bindings, and here we got the games and the softwares that use BGFX. So it's just proves that this library is capable of making AAA games, basically. So we got AirMech, I think it's a game, and we got a 3D software called CMF Studio, a game engine, a game engine, maybe the game engine, software visualizer, game, black shift, game engine, game. There's a lot of them, and there's some of them that they are well known, like Talking Tom, Pool, game, Talking Tom 2, engine. And the cool thing about it is Minecraft Bedrock Edition uses it, so that's why it supports multiple wide ranges of platforms. You got Xbox, you got PlayStation, you got Nintendo Switch, mobile devices, Windows, etc. Are you still working on? Yeah, I'm still working on improving Minecraft Legacy, but what I'm doing right now, I'm gonna implement a new rendering system and rendering library, yeah. So the cool thing about it is use Minecraft. Minecraft uses BGFX, and that's why it supports wide ranges of platforms, and it supports wide ranges of graphics APIs. So that's a big win for it. And not only Minecraft, it supports another thing. Where is it? Come on. Okay, there's a lot of games. It's in here. Yes, Minecraft vibrant visuals, like the shaders are written in this library's shader, basically. So I mean, it's very great, very great, and a lot of big companies use it. So I will try to make the render in it, so it can run on multiple backends and run on all platforms basically. So in this video I'll just like demonstrate how this library works, and I will not go a lot in detail, but I'm just gonna make a hello triangle using it. It's not hard compared to DirectX 3D 11, 12 and Vulkan. It's a mid-level graphics library. So I got a project called BGFX, and it's already set up with the BGFX library, and setting it up is kind of complicated. I don't want to do it while I'm live streaming, so I just made it in the behind scenes. So yeah, so the first thing that I will have is you're gonna need an main entry point in every C++ application, of course. So we're gonna say use the Windows API for making the window for now. So on the server. You saw on the server that other developers added version 1.14. They copied the code from the Minecraft PS4 edition and put it on the Minecraft LCMP PS4 edition. Did PS4 edition got leaked? I don't know. I didn't see it. But I know like version 1.14 is isn't like legacy anymore. It's the bedrock code. Like I don't know. I have no idea. I didn't see it. Sorry, man. But let's just continue. So as I said, I'm gonna just use the Win32 API just for handling window, and I will not use cross-platform because it's just a simple project. And yeah, so I'm gonna set up the width and the height. I'm gonna say 12080 by height equals 720. Just fix my mic. Alright, so the first thing we need to do, but they searched in the PS4 edition files. PS4 edition files. There's a PS3 edition. I haven't seen a PS4. I don't know. There's have been only. Let me just double check. Visual Studio. Minecraft consoles. This right? Yes. It's just PS3. There is no PS4, and 1.14 didn't came out. I mean, 1.14 came out in 2020 or 2022 maybe, and the last update for what do we say, for Minecraft Legacy Code was in 2019. So I don't think so. Maybe they backported it from Java code and so on, but in Sweden we say skitsamma. So the first thing we need to do is we need to create a window in Win32. So the way we do it is by registering a class, window class. So we're gonna say window class and define its content. So we can say window class h instance equal get module handle, pass as a null pointer, and we're gonna say give a class name. We'll just call it BGFX. So yeah, I totally forgot. I don't want to use Unicode, so I'm gonna say undefined Unicode, like so. And one thing, and it's define Win32 lean and mean, like so. Alright, so gonna write a long pointer function window procedure. Gonna just give it window procedure as it is, and then we'll register class. Register the class, and we create the window. So create the window, class name is class name, give it the name of the window, BGFX, the style of the window, Windows style overlapped window, position, I would just give it normal position, default, the size is width and height, parent window null pointer, h instance, null pointer, like so. Alright, we created the window. Now we would like to show the window. So we show it with this function, show, and update the window, like so. And we make our message loop, but before we need to define message. While get message null pointer 0u is bigger than 0. We're gonna translate the message and dispatch the message. Return message with y parameter. And now if we run the program, we will get a window, hopefully. Yes, we got a window, and that's it. But when we close it, it closes the window, but it doesn't exit our application. So we need to define it in the window procedure. So I'm gonna replace it with my function instead. So we're gonna say, give it the parameter that it needs, handle window, message, parameter, L parameter, and the return value is L result. And we just say switch the message that we get from the window, and we check if the message was window message close, and we just say post quit message. We just say to the message loop that we would like to just quit, and we return a default window procedure message, double parameter, L parameter, and yes. So now if we just run and if we just close the window close. Great. So after we have defined or created the window, it's time to draw some graphics on the window. So I'm gonna use the library that I said, and it's BGFX, and all right. Okay, but before defining the library or the BGFX and initializing it, there's one problem, and it's the width of the window isn't set really to 120/80 by 720. Like, it is set 1200 by 80. All right, it is, but the view rect of the window, the content that it displays, isn't the size that we have set. It's just the whole window is 1280. So we need to adjust it using its function. So the function is just using, but first let me just define a rect. It's 0 by 0 width and height, and we do it by just say adjust window rect, and we pass rect, give the style overlapped window, and no, it doesn't have a menu, it's false. And this function will adjust the window rect to the correct size. And the other thing that I would like to do is to place the window in the middle of the screen. I don't want it to place it randomly. Discord server, you found it on Discord server. Yeah, you could just add me on Discord server. PS3 support gone. I mean, I don't know. Like, I can surely try to get the PS3 build SDK and try to build with OpenGL. The 2019 edition PS4 file. Are they like, did they get leaked or something? I mean, yeah, dude, you can just surely send. You can send it on the server that I have created, our server, if you want. You just send it in general, and let me just continue my live stream, and I will see it. Enter x equal SA. We'll just get the system matrices. Get system matrix, and we would like to get the system matrix coordinate x screen and minus direct dot right minus rect dot left divided by 2. Yo, is that true? PS4 files? Yeah, but who did leak it? From 2019? The latest one? Let me just bloquear. Okay, got it. From like who said it? Did someone mention me here? Oh. PS4 files. Who is that dude, man? Who is this? I will just continue with my live stream and just check it out later. Let me just continue with my project till it's just downloaded, and I'm gonna fix my position of my window through Y, bottom, and top, and we just pass in the correct values XY, and we just say rect dot top, no, right minus rect dot left, rect dot bottom minus rect dot top, right? And now when we run the window, we will get the correct size of the window. Yes, and it places it in the middle. We just close it. Now we can begin with the BGFX. So after we create the window, we then initialize the BGFX. So we're gonna say BGFX resolution res bgfx platform data pd as platform data shortcut, and bgfx initialize. So we're gonna set the resolution width equal to rect dot right minus rect dot left. Same thing with the height. Bottom height, and we set the platform data equal to window handle, and lastly we're gonna initialize the bgfx. So we say resolution equal res initialize dot platform data equal pd, and here we define the type of the renderer we would like to use. We just say bgfx renderer type, and you got multiple renderers. You got Direct 3D, as we said, Direct 3D 11. They supported before Direct 3D 9, but they decided to stop supporting it because it's just old. And they got Direct 3D 11, 12, the PS5 or PS4 graphics API. You got Metal, I don't know what is, Noob, NVN, OpenGL Embedded System, Vulkan, WebGPU, and etc. But for now I'm just gonna say Direct 3D 11. And because I got two graphics card, I got a laptop, so it's got integrate and the RTX graphics card, so I'm gonna explicitly define that I would like to use the NVIDIA graphics card. So we say vendor ID equal bgfx PCI ID NVIDIA, and yes, now we can just initialize bgfx. So we say bgfx, if not bgfx initialize. If it couldn't initialize, then we would like to quit. So we just say destroy window, and we unregister class instance, no, class name and the handle instance, and we return -1, like so. Alright, second thing we would like to do is just get rid of the get message, the message loop, the Windows 32 message loop, because the problem with it, it's gonna block our window or block our main thread loop. Like if there's no message to get from the window, by the way, what I mean by message, I mean like window input, like keyboard, mouse hovering, resizing, closing, etc. If the window doesn't receive any messages, it's just gonna block the main thread, so it's not ideal for rendering. So we need to replace it. So we're gonna make a continuous loop that loops all the time and it doesn't stop. So we're gonna say boolean running equal true. I would say while running, and we check for message, but we don't use get message, we use peek message instead. And message null pointer 0u 0u, and peek message remove is bigger than 0. Same thing, translate message, dispatch message, and here we just say else, and in here we just update our game logic, the rendering, and etc. Alright, so we're gonna say bgfx frame, and frame is basically displaying the data that we we tend to draw. Like after we draw, we're gonna display them, and the bgfx frame is just present data on the screen. So gonna run it, test it out. Alright, it ran successfully, and we can notice the high usage of memory, and it's because Direct 3D 11 especially, and BGFX in general requires a lot of memory and requires a lot of processing in general. But it shows it works, and it's great. But if we try to close the window, our loop stays actively. The application runs still in the background. We need to notify that the running variable that the window has already closed, so we just exit the loop. So we need to do that right now, and we do it by say if message dot message equal window message quit running equal false. And I forgot to destroy the window and unregistered class here, and it's very important. So we need to just say shutdown first for BGFX, destroy window handle, unregistered class, LPS class name, handle instance, and yes. But you notice that when we ran the application, we saw just a white window, and we didn't display really graphics. And the reason is that BGFX will not update our frame buffer unless we submit data to it, unless we tell it to draw something. And now we don't have anything to draw, so we can just say to it to update the frame buffer with anything, any kind of data. So we use BGFX touch and use the view ID, and we're gonna discuss about view ID later. And if we just do it, we're gonna see a black screen, and this is basically the Direct 3D 11 viewport, and it uses my NVIDIA graphics card, which is amazing. All right, cool. Alright, after we initialize our BGFX, it's very important to set our view port, or we say view rect in BGFX. We give the view ID to 0. It starts at all the way up top and all the way to the bottom, so it's basically raise the width, raise the height, like so. And we like to set the view clear to the view ID 0, the flags BGFX clear color or BGFX clear depth, and give it clear color. I will just say gray for now, and we run it. We'll see a gray background. Good. Close it. Alright. Okay. So the other cool thing about the BGFX that is supports debugging in general. So it supports debugging, as I said, but we need to enable it. So we need to say set debug, and these are all the debug values that we can use. BGFX debug profiler, stats, wireframe, text, etc. But we're going to use BGFX debug stats, which is going to display the frame rates that we are currently in, and we are building for debug for now. And here you got the stats, and let me see, we're not drawing anything, so we're basically just getting 6000 FPS, and the reason is because I'm using a laptop GPU and I'm streaming, so behind the scenes I usually get like maybe 8000 and so on. But this is Direct 3D 11. We can in fact say we can change the graphics API directly, like we can run Direct 3D 12 instead, and you will notice that it takes 1 gigabyte of RAM to initialize itself, and the frame rates isn't great. It doesn't mean like Direct 3D 12 is bad by the FPS we are getting, because Direct 3D 12 is tend to be used in a large scene with a large amount of triangles, and basically in an environment that there's no way that Direct 3D 11 can render by itself. So that's why we're getting low FPS, and then that's completely normal for Direct 3D 12. And in fact, we can just try to render Vulkan. Let's try Vulkan. Alright, Vulkan. And Vulkan getting around 2000 FPS. Yes, that's true. Let me see. Maybe OpenGL. Let's try OpenGL. For some reason doesn't update the view rect correctly. Ah, it's fine. 4000. I mean, it's not bad. It's good, partially. But I will stick with Direct 3D 11. Alright. After we did initialization and so on, we can start rendering a hello triangle using BGFX. Like, why not? So yeah, here I'm gonna define my vertices for my triangle. Basically, I'm gonna make a struct, call it vertex, which is gonna have float x, y, and z, and unsigned integer color, which is a alpha, blue, green, R. And we're gonna define our vertices basically. So we say vertex try equal to negative 0.5f and negative 0.05f, 0.0f, and give it color 0xff, 0000ff, 2, 4, yeah, that's true. And duplicate that. I'm gonna change the vertices 0.5. I'll leave it negative, and here 0.5, and here just 0, and fix the colors. PS4 edition file? No, I didn't do it. I will do it now. Let me see, did I download? No, it's still decrypting. Alright, taking time. Maybe because I'm streaming, so the internet is not good now. Vertex try, and we need to define the indices of our triangle. So we say indices equal 0, 1, 2, and word is basically unsigned short, but it's defined in Windows 32 API. Alright. Now let's summer everything. We define a vertex point. A vertex is basically a 3D point in 3D space, basically, or corner, 3D corner, and it's got its values x, y, z, which tells where is the position, yeah, and its color, the vertex color, and the triangle contains 3 points, as we all know, that we learned in middle school. We define them in its 3D space, basically, and we give it the color, and the color is basically red. This is the red color, and yes, we do it with the other points as it is, and we got the indices. But the problem is we cannot send the data as it is directly, because Direct 3D 11 doesn't know how to interpret this chunk of memory, because at the end of the day, this isn't represented to him as, oh, it's X, Y, Z, and a color, same thing, etc. It needs to know, there's need to be a layout that describes that how this chunk of data is being laid out. So the way we do it, we use BGFX vertex layout and layout, and we're gonna define the layout. So we type in layout.begin, and then say add BGFX attribute position. We call it the first attribute is gonna be the position, and then we're gonna say how many values is it. There's 3 of it, and now we're gonna say BGFX attributes type. We're gonna tell it what kind of data type it is. It's float, and we move on. Add the next element, which is color, and we just say BGFX attribute color 0 4, and the type is BGFX attribute type unsigned integer 8, and would say yes, I would like to have to be normalized, and we say end. And you might say, alright, this is unsigned integer, why did we say unsigned integer 8 here? Because the colors are represented in each byte, and unsigned integer is already a 4 byte. So you can think this as like a union, alright? Inside of it contain unsigned char A, B, G, and R. So the value you write in here is the same thing as being written here. So let's say vertex v dot a alpha, we could just 0xff, v dot b equals 0x00, v dot g equals 0x00, v dot r equals 0xff. And this data that we wrote is the same thing as saying v dot a dot abgr, like 0xff 0000ff. It's the same thing, but it's just tell you how it's spread out in the memory. So yes, so now we have defined the vertex layout. Alright. The other thing that we need to have is the shader. So we need to create a shader using the BGFX shader. So gonna define a shader code right now. We'll call it vertex shader code, and yes, and there's another file that we need to have, and it's called varying.def.shader code, and it's very important for BGFX. In here we say vec4 b color 0, the attribute is color 0, we give it a default value vec4 1.0 0.0 0.0 1.0, and we define vec3 a position, the attribute is position, vec4 as a color 0, a color 0, Yeah, it's taken long. What did happen? I don't know. I hate Mega. I'm not comfortable with Mega. Inactivera. Alright. Let's just continue. Alright, we defined varying. Now I'm getting sense to take out my nicotine pouch and I need it. Snus. Ska snusa, fy fan. Speaking Swedish. Oh, good. Guys, have you ever tried nicotine pouches? It's a game changer. I swear to God. Alright. Let's continue. Gonna write here the vertex shader. The vertex shader takes in inputs and outputs. The input is the A position and A color 0. The output jailbreak Xbox One. Yeah, it's possible. We can install the version on it. I mean, as long as someone has the build SDK for Xbox One, then it will be easily for us to make a port with the legacy code edition, legacy console edition of Minecraft that got already source leak and that isn't being modified by anyone. The same original code, we can just literally compile it to Xbox and run it, because it has, like, in here Xbox, and it's like even Windows 64 or Windows basically in general, it has like the support of running Xbox in general. And Windows is the same thing, like it uses Direct3D 11 and Direct3D 12, and Xbox is the same thing, uses Direct3D 12. Like Xbox is running Xbox is basically running Windows operating system, same thing, but with limits, I guess. And for output, we're gonna output the color 0, and the output v color will be for the fragment shader. So we're gonna write now the vertex shader and the fragment shader later. Gonna include import thing, and it's bgfx shader dot shader header void main. Oops. GL position equal multiply the U model view projection with vect for a position 1.0 and the V color equal to a color 0. You know that 4J wanted to add a fourth minigame, but Microsoft cancelled development in 2017 because bedrock. No, I didn't know about that fourth minigame. What was it? Do you know? If you know, you can tell because I have no idea. And I really want to know what is it. Alright. Alright, we wrote the vertex shader. Now we're gonna write the fragment shader. So we're gonna say fs dot source code shader code. Wish we lived in a timeline where legacy was the one ported everywhere. Lol. I mean, the legacy console edition isn't like really a cross-platform, because you saw here we got a different builds for different consoles. There isn't like a unified system, like there's isn't like unified code base. Like every code base has its own set of how do you say, sets of rules and its API. Like the Windows build is meant only for Windows. It isn't meant for PS3 or PS4 and so on. Bedrock, the cool thing about it, it's cross-platform. So basically the code base could run on every operating system, on every you could say builds or consoles. And we saw basically that BGFX, the rendering library, they use it, and it's basically run on every platform. So they write one code base and they do it. That's why they started developing with Bedrock. It's not because they want money. I mean, of course they want to get more money of it, but it's better idea to start on a new code base. And that's why what I'm doing right now, I want to start on a new code base that is basically open source to everyone. So we're gonna write now the vertex, the fragment shader. So we're gonna input v color 0, include the BGFX shader dot shader code shader header, say void main and say gl frag color equal to v color 0, like so. Alright, now we wrote the shader. Now it's time to compile the shader. So we're gonna make a batch file. I would call it shadercomp.bat. Gonna write at echo off, and gonna use the BGFX shader compiler because it works only in BGFX shader compiler, of course. And I defined it already. It's in my D drive, and it's in void BGFX slash binary slash shader cdebug.exe. The file is vertex shader.share code. The output, I will output to vertex shader.binary. The type of it's obviously vertex shader, and the platform we're targeting is Windows, and the profile is the high-level shading language. We are using Direct 3D S50, and the include path for BGFX shader is, I defined it already, like so. Alright, gonna duplicate that, do it for fragment. shader. Alright. Fourth main game, build paddle. Oh, what a shame. Build battle. It would be a very great game if it's got released. Like, build battle is a must to have a legacy console. Oh, what a shame. Oh, Swedish we say stackare. Shit. Alright. Alright, we're gonna build compile the shader. I'm gonna say shader comp. Where is it located? I mean, it's here. Directory. cd bgfx shader comp.path. And there's an error. Okay, what's wrong? Let me just comment this out. Let's see. Did I define it correctly? Varying.def.share code. See you later, my dude. Go eat. I need also to eat, man. Weird. Of course, I'm gonna improve the code. Bye bye. Why is it happening? The error is, let me see, vertex shader. Oh. Oh, bro. Oops. Guess this is the problem. Nope. V color 0. Okay, it did compile. Nope, it didn't compile for fragment shader. It's gotta be this instead. Alright, it did compile. Great. Alright, now we got the shaders. Now it's time to load the shader and create the shader program. So we're gonna say, take this down, not all the way down, just keep it like this. I'm gonna say bgfx shader handle vertex shader, and we need to load the shader. Of course, I forgot. I need to create a function for it to load the shader. Alright, we're gonna say const auto load shader equal to const char pointer file name, and it's gonna return bgfx shader handle. Alright, so we're gonna say handle h file equal create file f name generic read file share read 0 open existing file attribute normal 0. We're gonna check if it exists. Valid handle value. Oops. If it couldn't open, we're gonna say bgfx shader, or no, invalid handle. And we're gonna get the size, large integer size, get file size, extended h file size, and we're gonna say we're gonna create a buffer h global buffer equal global alloc long pointer size quad port, and we're gonna read, so read the data, read file h file buffer byte read size quad port red 0, and then we're gonna say const bgfx memory pointer memory equal bgfx make reference to buffer size quad port, and release function, which is gonna take void pointer void, just leave it like this for now. I'm gonna say here global free pointer null pointer equal null pointer. Alright, and then I'm gonna return return bgfx create shader memory, and then, or before, close the handle h file. Alright, so we got the function that load the shader. Now we're gonna define our vertex shader, bgfx shader handle vertex shader equal load shader. It's called vs dot binary, and bgfx shader handle fragment shader equal load shader fragment shader binary, and then we'd say bgfx program handle program equal bgfx create program, which we're gonna say vertex shader fragment shader, and we would like to delete the shader after creation. True. Alright, Now, after we create the program handle, we're gonna create the vertex buffer handle, which will store our vertices. Take this out. We're gonna store basically our vertices in a video memory, VRAM. So we're gonna say VGFX vertex buffer handle equal create VGFX create vertex buffer, VGFX make reference to try, size of try, and we give it the layout. And then we create BGFX index buffer handle IBH equal BGFX create index buffer BGFX make reference try indices, size of indices, and yeah, we're almost done. Now we can draw to the screen, so we can just remove touch and we just say BGFX set transform. I'm just gonna say null pointer, no transformation, and we just say BGFX set vertex buffer to 0, vertex buffer handle, and BGFX set index buffer to IBH, and we submit to BGFX to the view ID 0, and we give it the program handle, and hopefully we will see a triangle on the screen after the hard work. And no, there is no triangle on the screen. What a shame. What a shame. Weird. Submit. I mean, we should technically destroy our data IBH and vertex buffer handle and the program, but it doesn't resolve the problem, and that's pretty weird. If I take this and just place it here, nope. Let me check for error handling. BGFX is valid. Vertex shader, it's not, return -1. Set the breakpoint here. Same thing with the vertex shader, fragment shader, and the same for program. Run. Nope. Alright, that's a pretty weird problem. If I remove this, maybe. Yes, now. Alright, it's working now. The problem was maybe I just use union and it's not familiar with union, but it's working. We're getting 5000 FPS and this is our triangle. Congrats. And we still We can change the graphics API to Direct 3D 12. And we'll still get the same results. Which is great. We can change it, like let's say we're gonna use Vulkan, but we need to compile our shared program to Vulkan. So it's I guess speed per 10. Nope, just forgot to compile the shader. We'll get an error. Yes, an error. Unknown profile. Did I spell that correct? Kind of. Run it. Alright. Compile it again. Alright, it works. Run it. Yes. We didn't change the code base. Same code base, but with two different graphics API. Which is great. Alright, what is the time? 9:15. I think I need to end the live stream. I will just thank you guys for watching my live stream, and I hope you all have a great time, and I will see you in the next live stream, of course. So have a nice time.